Hi, this is Miss Park. This is continuation of graphing and naming trig functions. This is naming trig functions. So in the previous video, we learned how to graph a trig function that has this equation. So the a, k, p, and q around sine x or around cos x. And we learned how each of these a, k, p, and q affects the key properties. So I'm going to work backwards now, given the graph, coming up with the a, k, p, and q, and then writing the equation. So this is in your booklet, so it's page 186, and I'm going to go to just look at example 1. So look at example 1 carefully. We can see a few things. We can see that the maximum is 1, and the minimum is -1. We can see that the average is 0. Okay. We can also see that the amplitude is 1. So remember, the amplitude is the half height. It's the distance between the average and the max, or the average and the min. And we can see that that distance is 1. And if you want, there is a formula. The distance between the max and the min is max minus min. And because the amplitude is half of that distance, then amplitude is max over min divided by 2, max minus min divided by 2. So if you have difficulty because the numbers get complicated, then that's how you can figure out the amplitude without estimating. Okay, and then that's everything. Oh yeah, there's one more thing. The period is 360 degrees. Right, so we can see that nothing has been done to this graph in terms of transformations, except that this is starting at the average and going down, and then back average, then max and average. We don't have sine and cos don't look like this, but this looks like sine. Difference is sine starts at the average and goes to the max, and then down to the average, min, and back. So this looks like a reflected sine. Right? This is the vertical reflection. So I can put things together. So I'm just going to write my key properties from so I'm going to write my a, k, p, and q from the key properties. So my average sits at 0, which means there's no up and down movement. There's no vertical translation. So that tells me that the q value is 0. My amplitude is 1. So there's no vertical stretch, but it is reflected. So I know that my a value is -1. My period is 360, which means there has been no horizontal stretch. So I know that my k is 1. And what's left is the phase shift. Well, I am starting at the y-axis. So let me write over here. Start at 0 degrees, therefore phase shift. So therefore no phase shift. All right, and so then I can say my p is 0. Okay, and now I can put them all together. So it's a sine, so it's going to be y equals a sine k x minus p plus q. And now I'm going to replace all my things. So y is going to be -1 sine. Now my k is 1 and my p is 0, so that's just going to be sine x. And then my q is 0, so plus 0, or in other words, y equals negative sine x, and that's it. I'll put this in a box there. All right, so that's the equation, y equals negative sine x. All right, so let's do one that's a little bit more interesting. So I'm just going to flip in the booklet. You have so many you can do in the booklet. I'm going to go down to example 8. Okay, go down to example 8 so you can see this one looks very different. All right, and let's start writing our key properties. So our maximum I can see is -1. Our minimum is -3. All right, so now I can calculate the average. Our average is going to be -1 plus -3 divided by 2, right? The average of two things, you add them up and divide by 2. So that's -2. So that's already giving me the q value. Let me write this down. Q is -2. Okay. My amplitude is the distance between my average and my max, or my average and my min, okay, which is going to be 1. But if you want to use a formula just to be sure, it's the max minus the min divided by 2. And that's going to be positive 2 divided by 2, which is 1. Okay, so I know that my A is going to have a 1 in it. We still don't know if it's 1 or negative 1. So we'll do that in a moment. Okay, then I have to look at my period. So I'm going to find, here's a place to start. And then I see this again. I see this place again here. All right, and so that's going to be, my period is 180 degrees. Now the K is how many cycles fit in 360. Okay, so how many cycles? If the period here is 180, then that means the K is going to be 360 divided by 180, which is 2. It's saying that this is a horizontal stretch by a factor of 1/2. This period is 1/2 the length of the period of the parent, right? It's 180, it's 1/2 the length. So that means the K is 2. So how you find the K is you take 360, which is the normal period, divide it by this period. That tells you how many cycles fit in 360, and that's your K. All right, so we have our Q, we have our K, we have mostly our A. We need one more thing, which is the P. All right, if I start with this point over here, then my P would be 0, because I'm starting right at the y-axis. So let me go no phase shift. So I will say my P is 0. Okay. Now, if I start here, then this is definitely not a sine, because sine would start at the average. So this must be a cosine, but cosine starts at the maximum and this one starts at the minimum. So therefore it must be a reflected cosine. Okay, so now I have everything, because if it's a reflected cosine and the amplitude is 1, then that means my A is -1. And so now I can write the equation, which is y equals -1 cosine, open bracket, my K is 2, bracket, x. Now there's no phase shift, so I'll just leave it like this now so you can see where they're coming from. And then the -2. So I can write y equals negative cos 2x minus 2. Right? This 2x you could put in a bracket or you don't have to. All right, but one more thing. That's if I start at this point, but remember we said with periodic functions, you can begin your cycle anywhere you want, right? So what if I didn't notice that that looks like a cosine and I thought, oh, you know what, cosine starts here. So maybe I'm going to start at this point. Let me use different color. Maybe I'll start at this point and go to this point. Same thing. It's still the same period, right? I still have a period of 180, whether I go this way or I go this way. So what I'm going to do is I'm going to give you an alternate equation for this graph, but starting over here. The max, the min, the average, the amplitude, the period, none of those things change. But if I start over here, the phase shift changes. So I'm going to write or start over here, which is 90 degrees to the right of the y-axis, or the phase shift is 90 degrees. Okay, I can start over here. And if I start over here, it's no longer a reflected cosine, it's just a regular cosine, right? Because it's starting at the maximum. So, all right, so I can rewrite the equation. So I can write y equals, so it's no longer reflected. So my A value is just a 1. 1 cos, okay, open the bracket, 2, and now there's a phase shift of 90 degrees, minus 2. All right, and if I want, I can remove this 1 because it's a 1. Right, sorry about the pen. Anyway, so, okay, so alternate. You got two different equations. I got this one and I got this one. Okay, two different equations for the same graph. By the way, could I write this as a sine graph? I totally could, because I could pick a point on the average. So let's say over here. Okay, I'm going to do it. I'm going to pick this point over here at 45 degrees. A little hard to read because it's in the middle of the box, but we know it's 45. And here's the ending. It's still 180 degrees between these points, but now I have a sign. So I'm going to write again, or the phase shift is 45 degrees, and it's a sine. So y equals, amplitude is 1, I won't write it, sine 2 x minus 45 degrees minus 2. So all of these answers are correct for this graph. It all depends on what you see first. Do you notice this point first? Do you notice this point? Do you notice this point here? They're all correct. Okay, and that is how you name the graph. So you're going to list the key properties, get your A, K, P, and Q from the key properties, and then write. Okay, and there are multiple correct answers for each graph. Okay, please practice. You've got a whole booklet of these. Thank you. Thanks for watching.